Again, welcome to Unit 3, Part 2 lectures. In these lectures, we are going to study about histogram and also charts. So our main objective is histogram and charts. We are going to discuss about pie chart, stem and leaf chart, plot chart. And this objective covers, I think, I'm not sure, but somewhere around question number two or three. Plotting a graph. Actually, we're going to plot an histogram. So what is a frequency histogram? A frequency histogram is more or less a bar graph, and we can see an example here, a bar graph that represents the frequency distribution. And so always the vertical, any frequency histogram chart, the vertical is always the frequency. Frequency, as we know, is the total number of tallies. So here we can convert a frequency distribution to histogram just by looking at the frequency distribution. The first column is the class. So the classes will be horizontal. So that's why you can see the bars have the same size. The width is the same because we remember in frequency distribution, we say the class width is the same size for all the classes. So that's why the bar chart width are the same. Then the frequency value will be the vertical line. And we will see an example. So a frequency histogram is basically a bar graph that's representing the frequency distribution. The horizontal scale, as we said earlier, the horizontal scale is quantitative and measures the data values. In this case, it will be the class values. So we may have a class for salary, the salary between 10,000 to 20,000. That will be, again, horizontal value. And if we have 20 or 30 employees that make that salary, then that will be the frequency. So the vertical scale measures the frequency of the classes. Frequency of the classes. So again, one of our questions in Unit 3 IP assignment is to convert a frequency distribution to histogram. And also a question was given that an histogram is given and they say what's the number for the classes. In short, how many classes we have. How many classes we have will depend on the number of bars. So for example, in this histogram, I have 1, 2, 3, 4, 5. I have 5 bars. So the number of classes will be 5. And also the class width will be the size of each bar horizontally. The frequency will be based on each class, how many frequency we have. So we have a consecutive bars, and these bars must touch each other. A bar chart, normally the bars doesn't touch each other. Yeah, the reason why they touch each other because again, the class values, they are very close. So the class boundaries will be the numbers that separate classes without forming the gaps between them. And this is a very good example from the frequency distribution. We saw the class and the class weight very close. So actually we are using frequency distribution here as an example. So we can see a class from 7 to 18, 19 to 30, 31 to 42. And this is our, again, frequency for each category. So the class boundary will be somewhere between 6.5 to 18.5. How do we get this? We can see the formula we use again. And here, 19 minus 18, excuse me. The difference, we see the color 19, the end of the first class 18, the starting is 19. 19 minus 18 will be 1. Then we divide 1 into 2 parts. That's 0.5. So we are going to reduce the first value by 0.5, then increase the next one by 0.5. And we do the same thing for all the classes. Because from 30 to 31, the difference is 1. When we divide 1 by 2, since we have the lower limit and upper limit, we divide by 2, we get 0.5. So reduce 0.5 to at the lower limit section, then increase 0.5 at the upper limit section. And it's the same since all is 111.5 throughout. So this will be our class boundary. Now, when we get this class boundary, we can construct again our histogram or frequency histogram. We know the midpoint, as we said earlier, is the average value between the lower and upper limit divided by 2. So 7 plus 18 divided by 2 will give me 12.5. 19 plus 30 divided by 2 will give me 24.5. And how do we get a class boundary again? One more time. We see that the difference from the first class upper limit and on the second class, the lower limit is 1. So 19 minus 18 is 1. So we divide 1 into 2. Then we reduce the lower class by 0.5, increase the upper class by 0.5. When we divide the difference into 2, we get 1, so it will be half and half. So that's how we get the class boundaries. So with this now, we can construct the histogram. So we can see that we have 12.5. Let me go back one more time. 12.5 midpoint. The frequency is 6. This is between 7 to 18, or the class boundary is 7.5 to 18.5. And again, the difference are the same value. The difference are the same value. It's again 11 between them. So that's what we have: 12.5, 6, 24.5, 10. This is the midpoint. Then we can again get the class width. We can see the bar height is the same. When we go back, the class width for each is the same, 11 throughout. And also here, the class boundary is 11 between the class width. This is the midpoint values. So for example, if I go to the third bar, I will see that the frequency will be 13, which is the third bar, the third class 13. So looking at the frequency distribution, I'll get my vertical values based on the frequency, and I'll get my horizontal value based on the class width. So in short, I can just start, okay, the first value start from 7, 18, 19, 30. So I can measure 7, 18, 19, 30, but again, we have to make sure they are close to each other. So this is again histogram or frequency histogram. The class width horizontal and the frequency is vertical. So here they say you can see that more than half of the subscribers spend between 19 and 54 minutes on the internet during their most recent section. And we can see from more than 19, excuse me. The subscriber minutes are here. So this is between 6.5, 18, here 4 from 19. So from here we are saying 19 to 54. And if they say more than half, let's say this is right. We got 10, 23, and 31. So more than half. The total is 50. So between 19 to 54, we have 33, which is more than half. So we also have something we call the frequency polygon. This is not in the question, but again, something we should know. A frequency polygon would normally be the line graph that emphasizes the continuous change in frequency. And normally the dots came from the midpoint. So the first class midpoint, we have them, we connect all together. And always we start from 0. So we can see our graph here. The first midpoint is 12.5, 24.5. So we have to plot all these points. And the frequency will tell us, for example, 0.5, 6. 12.5 was 6. Then 25.5, I think, was 24, it was 10. Then 36.5 is again 13. And we keep going. So those are the midpoints. Then we connect all together. So based on the data here, we have the midpoint and we have the frequency. So I start from 12.56, 24.5 is 10, the point, and then we connect all the points together. Now, since it's a straight line, when I connect the points together, I will just make this start for 0.5. Also, we have the relative frequency histogram, which means instead of using the frequency values, we are going to use the relative frequency. So we say this one has the same shape and the same horizontal scale as the corresponding frequency histogram, the same scale. The vertical scale measures the relative frequency instead of only the frequency. And the down measure the class width. So we can see we are using the same class boundary from our previous example, the class width. Now, instead of using frequency values, we are going to use the relative frequency. The difference now is that you can see that relative frequency, we find, of course, how do we get 0.12? We divide 6 by 50. If the total is 50, we divide 6 by 50, 10 by 50, so we use this point. The total for relative frequency always will be 1. So it's like finding proportion. So we can see that the shape is almost the same shape. This time we are using relative, because the higher the frequency, the higher the value of relative frequency also, because it's proportion, part of it, and part of the total. And the lower the frequency, also the lower the relative. So the shape again is same. Only this time, when we look at the vertical line, we are using the relative frequency value instead of the frequency value. We also have what we call the cumulative frequency graph. We already saw that in the frequency distribution, we saw how to find the cumulative frequency, which means we had that the first frequency is 6, the second frequency is 10, then the first cumulative frequency will be 6, then second will be 16 because we had 6 and 10. Then we keep adding till we reach the end. The end should be the total end data entry we have. If it's 50, the end. So that's why when you look at the shape at the cumulative frequency graph, it looks like it's increasing to the end because it never decreases. We always add in the previous value of the frequency we had in. So this is, the next one is the stem and leaf plot. And I think this is not also in the exam, but it's part of statistics topic on graphing. In the stem and leaf plot, we have a concept called a stem and also the leaf. This is a plot. What is there is that, actually, I'll use this example to explain. I have a values here. Now we always take the leading digit as the stem, and then the next digit will be the leaf. So when I look at the data set here, I have 20s and only 30s. So I may have we also have 40s, 145. So the stem, I'm going to use 2, 3, and 4. So we have 2, 3, and 4. Then we draw a vertical line. Then we look, also it's good to put it in increasing order, sorting. This data is already sorted for us. So first thing we should do is to sort it. So 21 means I have 2 and then 1. 25 means 5, 2 and 5. So the stem 2, we keep it. And then the last digit, we are writing 1, 5, 5, 6, 7, 8. 1, 5, 5, 6, 7, 8. Then the 30s, we have only 3, 0, 6, 6, 30, 36, and 36, so 0, 6, 6. Then 45, we have only 5, so only 1. So we can see that on the stem and leaf plot, it also can give us the shape of the data distribution. This looks like it's skewing to the right because we can see the shape is going this way. And we may talk about this more detail. So stem and leaf plot, always we start with the stem, which will be the leading digit, and then the leaf. And the purpose of using stem and leaf plot also is to organize your data. Now, by looking at this shape, I'll see that, oh, okay, most of the values are in 20s, but 20 is very long. Only 145 we have. So it's similar to histogram, as we said also, to organize our data. And the good thing between stem and leaf and histogram, you do not see the individual value. Also, okay, between 10 to 5, between 10 to 20, we have 10 values. But I don't know what value is, whether it's 13, 14, 16, but we know it's between 10 to 20. But with the stem and leaf, we can see the shape that 20s are a lot, but we also know what values they are. There's no 22 here. We don't have no 29. I can see the values. So that's the advantage of using stem and leaf. It also contains the original data value after we even get the shape. So this example given to us, the following are the numbers of a text messages sent last month by the cellular phone users on one floor of a college dormitory. Display the data in stem and leaf plot. So we have all this data set. And when I look at, first of all, before we decide what value to use as a stem, we have to look at it. We can see that all these values, they are 3 digits. So I don't want to use 1 as a stem. So the data entry goes, lowest is 78. And it's just only 1 value, if I can remember. Yeah, there's only 1 value. And the rest of the value is 3 digits. So the lowest is 78 and the highest is 159. So we have to see which values to use. So here we say, okay, if it's 78, then we can say, okay, 7 and 8. 159, since we start with a single digit 7, we can say, okay, the leading digits will be 15, then 9. So the list will stem from 7 to 15 then. So we may have 7, 8, 9, 10, 11, 12, up to 15. But we can see that most of the values, we don't have 80s, we don't have no 90s. So we start from 78. In 100, we have 105, 108, 109, then 110, 120s, 130s, 140s, and 150s. So we can say, okay, this shape looks like almost symmetric because 12 is somewhere in the middle and have the highest. We may change the concept a little bit. Here is the number of tests sent, and the same thing, but here you can see that we have the same values, but we have the 11, 12, 13, 14, 15 in ordered. So this is best way. See, we have 5, 8, 9, then 2, 2, 2, 3, 4, 4, 7, 8, 7. So this is more easy than to have it on order. So we have 6, 116, then 114, then 112, 112. So the best way, again, both of them are correct, but it's good to put them in order, which make it more simple, very fast to identify each value. I don't, for example, a question was asked, do we have 128? I don't want to go through the list from beginning to the end to see if I have 128. But here it's ordered, so I'm go straight to 6. So, oh, there's no any value between 6 and 9, so I don't have 128. So the ordered is more easy to identify each values, but the shape are the same. You can see both of them, whether it's unordered or ordered, the shape are the same. We also have what we call a dot plot. A dot plot also is more or less like a stem and leaf also. It can give us the shape of the data. But this time we draw a vertical line. We look at the data set from the lowest to the highest. Then we can plot a long line. Here we saw that the lowest is 21, the highest is 45. So we start our line from 20 to 45. Then we draw a long line. We scale it. We have to scale the line. Now each value you put a dot above it. So 21, I have a dot. 25 came twice, so I'll have 2 dots. 26 only one dot. 27 is 1, 28 is 1, 30 is 1. 36 is also 2 now. If it's 3, we still put the 3 in the same vertical line. So from here, I can, again, see my data is more organized than looking at the values. So a dot plot, first step, draw a straight line. Second, scale the line. And thirdly, look at the values and place the values on each number that they belong. If the values is more than 1, then you have to arrange it in a vertical order. Since it's 36, I can't put it in 37 or 35. So you have to be on top of each other. So this example given on constructing a dot plot. They say we should use a dot plot to organize the text messages data given to us. Now we look at the lowest value and the highest value, and we came up that we need a line to draw between 70 to 160. Why? Because the lowest value was 78, and I think the highest value was 158. This is the same values we used previous example. Still like 159, sorry. So the highest is 159, the lowest is 78. So we decided to plot a line from 70 to 160. And we should say it's 70 to 160. Then we take each value. So we can see that 125 is a lot. We have like 5 125s. So we can count it here. 125. Maybe it should be 126. You see, it moved one step. So 126. We have 126, 1, 2, 3, 4, and we should have 5 somewhere. 1, 2, 3, 4, and 5 somewhere. But again, the whole concept is plotting the values on each. So like, for example, 105, we have 1, should be somewhere. And that's how we do it. Then the next one is the pie chart. The pie chart normally is a circle, so it's like 360-degree circle. So a circle is divided into sectors that represent the categories. So if I have 360-degree, if I have 20% or 20 degree of something, then I may cut 20-degree part, etc. So the area of each sector is proportional to the frequency of each category. So let's say we have a frequency distribution here. This we normally call frequency table because we are using labels for the classes instead of using values. So class, frequency distribution, the class will be quantitative values. Frequency table, the class will be a label like vehicle type. We have cars, trucks, motorcycle, and others. So this is an accident that happened. We have 18,440 killed in car accident, 13,778 killed in trucks, 4,553 killed in motorcycles, then others is 823. This is a data set most likely from the Motor Vehicle Department, or in this case, U.S. Department of Transportation, National Highway Traffic Safety and Administration. So we can plot a chart here. So all we need to do now is we need to find the part of cars, trucks, motorcycle, and others. So to find the part, it's like looking for a proportion or relative frequency. I will add all the total, then I will divide 18,440 by the total, 13,778 by the total, 4,553 by the total, 823 by the total. Then we get the part for each. And that's what we are doing here. So we are looking for the relative frequency first. Then we can change this to percentage. So it's like 49%, 37, 12, and then 2%. So next, since circle is a 360-degree, we are going to convert it. So central angle for cars, since cars is 49.49, this will be in radian. We just multiply by 360 to give us in degree. And the same thing we do for the rest. So 360-degree multiplied by 3.37 will give me 133 degree. 360-degree multiplied by 0.12 will give me 43 degree. 360-degree multiplied by 0.02 will give me 7 degrees. So the total here should give me 360. And I'll use this to plot it. So next we have something called the Pareto chart. This is a vertical bar graph in which the height of each bar represent the frequency or relative frequency. Now the difference between the histogram and this is that we have interval between, but we still have frequency and categories, so classes. And this bar normally have to position in order of decreasing height. So we know, for example, in histogram, if the first value is the shortest, we put it in the front. If it's the longest, we put it anywhere. In histogram, we go by the class values. But since this is a label, we can say, okay, we put the increasing one first. So Pareto chart, normally the categories have to be labels. It cannot be quantitative, because if it's a quantitative values, I can't, if the, for example, if I have 5 to 10 and I have 10 to 20 here, I can't say because 10 to 20 is long, I'll bring it in front of 5 to 20. No, we go by the values, the scale. But if the data is labeled, like let's say this is a truck, this is a motorcycle, this is a bicycle, etc., then it doesn't matter. Truck can come front first or bicycle can be in the front. It's just a label. So parental chart, we normally categories are labels. We also have the paired data set. And this concept is almost like scatter plot. So we have y and x values. And we pair each point have a x value and y value. So we graph it. So graphing using a scatter plot, because each point have x and y coordinate 2 dimension. So if I know the x value and y value, then I can plot the point between. So this is an example given here. They say a British stat Ronald Fisher introduced a famous data set called Fisher's-Harris data set. This data set describes various physical characteristics such as the pattern length, pattern width in millimeters. For 3 species of Harris, the pattern length form the first data set and the pattern width form the second data set. The source of this data is given. So when we plot this, we can see our Harris data set here. We have here, we are plotting the pattern length with the pattern width. And based on the data set, we can see that, oh, okay, as the pattern length increases, same thing, the width also increases because this is in increasing order. So scatter plot, we can use it to find the relationship between 2 variables. In this case, the pattern length and the pattern width, which is vertical and also horizontal value. And we still have the same increasing. So from the scatter plot, you can see that the pattern length increase, the pattern width also tend to increase. And this will be the conclusion of, again, Unit 3, Part 2 section. Here, again, is a statistics topic, not discrete. And we discuss about the frequency, histogram, and also charts, other charts. So we discuss about what is a scatter plot, parental chart, histogram, and also bar chart, stem plot, and dot plots. These are some of the few charts we use to visualize our data in statistics. Again, thank you. And this covers again Unit 3, Part 2.